Okay, hi guys. This is kind of my first video experimenting with not only the Notability app and recording that, the Notability audio, which if you have the Notability app, you can play that back and kind of watch all the pen strokes in real time, but also just making a screen recording on the iPad, which then hopefully I can post to YouTube and everybody can watch this, which would be great. Today we're going to work on, this is lesson 8.8. This is on completing the square, and the assignment for you guys in my class is to do 3 through 30 every third. And this is one lesson where I think it really, it will behoove you to really watch this whole video and for me to go through this carefully with you. Of all the lessons we've done all year, this one can tend to be one of the most difficult at first to comprehend. And so I think it's worth you listening and watching my explanation for what this all means. What does completing the square means? What does completing the square mean? Excuse me. So what I've done here to begin this Notability document is I've already written out some stuff that kind of encapsulates the big idea or the main idea. And I'm going to walk you through some of that, all right, and highlight a few things as we go, okay? So the big idea behind this lesson is that completing the square refers to means creating or completing a PST, okay? PST, remember that, PST, perfect square trinomial. Completing one where one didn't exist before. So recall what a PST is, okay? Perfect square trinomial. And here are kind of your definitions of perfect square trinomials, okay? Those are the official kind of algebraic formulas for a perfect square trinomial. A squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, okay? Remember the way I explain it. The key is you've got a square value here, okay, a square expression here in a squared, and a square value here in the b squared, and in the middle, you've got double the product of the two roots of those squares. Now, I know that's wordy, but that is what it is, okay? And here's some examples. If the algebraic expression version of those, kind of the official versions, kind of scare you a little bit, here's some kind of more kind of real-worldy expressions. Look at the next one here, okay? X squared plus 10x plus 25, okay? Notice x squared is a square, okay? 25 is a square, okay? And what's the root of x squared? X, right? What's the root of 25? 5. And what's 10x in the middle here? Well, it's double the product of 5 and x, right? 2 times 5x is 10x, okay? Now, why do we like these so much, okay? The reason we like them so much, recall, is how they factor, right? This factors as x plus 5 squared, okay? We're going to talk more about that in a second, okay? Here's another one, okay? X squared minus 14x plus 49, okay? Again, square here, right? Its root is x, all right? Square, here, let's make that a little bit better. I think we can clean that up a little bit. Okay, so x squared obviously is a square right there, and its root is x. Okay, 49 obviously is its square. Now its root is 7, but it could also be, you could say 7 or negative 7, right? And when you get negative 14x in the middle, well, that's 2 times negative 7x, right? So again, how does that factor? It factors as x minus 7 squared, okay? Even something like this, a little larger, 4x squared plus 20x plus 25, this also could be a PST, okay? Let's take a look at the first term. Is that a square? Yes. What's its root? 2x, right? Let's take a look at the third term. What's its root? 25. Its root is 5, right? And if you double the product of 2x times 5, 2x times 5 is 10x, double that, you get your 20x in the middle, okay? So how does that PST factor? Well, it factors as 2x plus 5 squared, okay? So PSTs are good. Think of PSTs as your friend because they factor kind of so efficiently, okay? They are perfect squares. We want you to be able to notice them. We want you to kind of spot them on contact, okay, when you see them. So it's important that you know your squares and recognize your squares, okay? Now, to reiterate something I've been saying, why are PSTs so helpful, okay? Because of how they factor, all right? So again, let's look at this explanation. I've already gone through this once, but let's look at it again. X squared plus 10x plus 25 is a PST, all right? This is a PST, okay? And then that takes you to the factored form of x plus 5 squared. Now, the next question is, why is that so helpful, okay? Why is it so helpful that we can factor it like that? And here's the big kicker. Here's the big idea for this whole lesson, because if you can get an isolated binomial squared, okay, in an actual equation, right, we're going to be solving equations, then you can, here we go, take the square root of both sides, okay? That's the big idea here, okay? So let me walk you through an example, okay, that illustrates this idea. Let's say we actually have an equation now that's x squared plus 10x plus 25 equals, let's say, 16. It'll be helpful to have a square value in this initial example on the other side. We don't need to, but you'll see why I did this the way I did this, okay? So how does this whole PST factor, right? It factors as x plus 5 squared, right, equals 16, okay? And then why is that so useful that we can factor it like that? Because then we can take the square root of both sides. Not forgetting to write that plus or minus there, of course, right? That's very important, okay? So then that becomes x plus 5 equals plus or minus 4. And we're back to the prior lesson. As you recall, we're back to lesson 8.7 now, right? Where we applied the principle of square roots, just took the square root of both sides. And now we have that situation where we have two possibilities, as you recall here, either x plus 5 equals 4 or x plus 5 equals negative 4. And we can solve, okay? Subtract 5 from both sides, we'd have negative 1. Subtract 5 from both sides, we would have negative 9. And those would be our two solutions, okay? And we got those two solutions, and kind of all went back to the fact that it was so easy to factor that perfect square trinomial, okay? Now here's a fun fact, just an FYI. Look at these two answers here, okay? Those are both, not only are they real numbers, they're rational numbers. They're numbers that can be expressed as fractions. There's a simple way to think about it is there's no radical in them, okay? They're rational numbers, which tells you that if you get answers like that, the initial expression here was factorable. We could have done this another way. Let me just show you really quickly because I don't like to leave anything out. That if we do that whole equation again, another way we could have done it, is to do this, subtract 16 from both sides to set everything equal to 0. So what would we get here? Plus 9, right, equals 0. And then this factors, right? Not as a perfect square trinomial, mind you, but just as a normal kind of trinomial, x plus 9, x plus 1, right? And then you set each factor equal to 0. Set each factor equal to 0 and solve, and there's your negative 9, right? And here's your negative 1, okay? So that's a way you could have done that. And in fact, we would want you to do that. If you had complete choice on what's the easiest way to solve this equation, okay, this is the easiest way, all right? This is easiest, okay? Maybe, okay? But if we scroll back up, okay, this is also pretty easy, okay? And it's the idea of completing this, of using a PST that factors, okay, this step right here, okay? Let me do another example for you with something where, again, we're going to complete the square, but it wouldn't be factorable, okay? Let's do another example. Let's do another PST type of trinomial, x squared plus, let's say 4x plus 4 equals, and I'm going to say 7, okay, this time, all right? So again, hopefully you notice here that this expression, okay, is a PST, okay? I'm going to back that up, okay, but hopefully you see that, okay? And how does that factor? That factors as x plus 2 squared equals 7, okay? And we like that because what can we do? We can take the square root of both sides, okay? Not forgetting to write plus or minus there on the root 7, okay? And so that gives us, forgive me, okay, x plus 2 simply equals, and here you just write plus or minus root 7. That's all you have to write, okay? And that's fine, all right? And then your last step is to subtract 2 from both sides, and here's how you're going to write that kind of an answer. You're going to put the negative 2 first, okay, the real number first, and then, excuse me, the rational number first, and then the radical expression. So negative 2 plus or minus root 7. Negative 2 plus or minus the square root of 7, okay? So again, this all goes back to like why PSTs are so helpful, okay? Because they factor so nicely, which then lets you take that square root of both sides, okay? That's the big idea. So back to what we call completing the square, okay? This has all just been kind of warm up so far. So what does completing the square mean, okay? So here's an example. Like let's look at number 3 in your actual homework set, okay? They're giving you x squared minus 4x plus basically a big fat blank, okay? Which is asking you what number there would make that a perfect square, a completed PST, okay? What makes this a PST, all right? And hopefully you can see, I'm not sure you can see it, but hopefully you can see that that value needs to be, tap my pencil, and whoop, there we go. That value needs to be 4, okay? Why does it need to be 4? Because now it is a PST, right? And how would this factor? This would factor as x minus 2 squared, okay? Now, if you're looking at that going, I don't know how he got that at all. How did he know it was 4 and not 5 or 7 or 3 or what? Okay, well, couple answers, okay? First of all, please, I want you to notice that that is a square, okay? 4 is a square, okay? And it does factor like that, okay? But the question is, what's kind of the algorithm? What's the algorithm for getting to that number? Oops. What's the algorithm for getting to that 4, okay? And the algorithm is as follows, excuse me. Okay, the algorithm is as follows. Here's what you do. You look at this coefficient here, the negative 4, okay? And what you're gonna do is divide it in half. You're gonna cut it in half, okay? What would that give you? That would give you then negative 2, right? And then what are you gonna do with that negative 2? You're going to square it, okay? And that's gonna give you that mystery value of 4. And that completes the square. It makes it a completed perfect square trinomial, all right? That's the idea behind doing that. So let's look at another problem. I think we're actually going to launch into the homework now because I think sometimes just by doing these problems can help a lot, okay? I can use doing the problems as a means of explaining why completing the square is valuable. So let's go on and look at number 6, okay? So here we have x squared minus 8x equals 9, okay? So recall that before what we would have you do is subtract 9 from both sides, okay, and then try to factor it. But what we're going to try to do here instead is with all this, okay, this is 2 terms out of 3. It's just a binomial right now. We want to complete it so that it's a perfect square trinomial, okay? What number added to this, okay, would complete, what number would complete it as a PST, a perfect square trinomial, okay? Forgive the messy handwriting, but hopefully you get the gist of it. What number would complete that, okay? So let's kind of go through the steps. We have x squared minus 8x, okay? So what do? We're going to take half of that value, that coefficient, okay? We're going to take half of that. That's going to give us negative 4, all right? And then what are we going to do with that negative 4? We're going to square it, okay? And that's going to give us our mystery value of plus 16, okay? Of plus 16. So that completes the square. Now, what we need you to realize is that you can't just go in throwing an extra 16 onto one side of an equation without what? Doing it to the other side. So if I add in my 16 here to complete the square on that PST, then I must add in 16 here on the other side, okay? This whole thing, okay, this is the big idea, okay, of this whole lesson, all right? What we just added in here, we added also to the other side, okay? All right, this is the work of equations, right? Whatever you do to one side, do to the other, okay? But see how clever that is, because now what can we do with this PST? We can factor it. And how is that going to factor? It's going to factor as x minus 4 squared, right? And on the other side, look what you get, 25. Aha. Okay, so what can we do next? I think you know what's coming. Now that we have this binomial isolated as a square, right, we can take the square root of both sides. Yay, right? That's the whole idea behind this, all right? So now we have x minus 4 equals plus or minus 5, which gives us our two equations, either x minus 4 equals 5 or x minus 4 equals negative 5. Okay, and we can add 4 to both sides. We get x is 9. Okay, add 4 to both sides. We get x is negative 1. And we are done. How about that? So that's the concept of completing the square, okay? So you might want to kind of scroll back up and look through those steps again and see what we did. Now remember what I was telling you about, the fact that these are rational solutions, okay? Rational solutions means, okay, that we could have factored, okay? Factored originally, okay, without completing the square. Now, in this lesson, obviously, we want you to complete the square just to learn how to do it, to practice it. And there'll be some where you have to complete the square, at least until we learn the quadratic formula, which is coming up next, okay? All these things are interrelated, by the way. All of them kind of have their place, all right? But let me show you that problem again, okay? So that problem, okay, done an easier way. But we don't want you to do this in the homework. Just FYI. So what did we have? We had x squared minus 8x equals 9. Okay. We could have just subtracted 9. Okay. And in general, this is the way you would normally proceed. Okay. You want to set things equal to 0 generally when you have quadratic equations. Okay. Whether you're going to factor it or whether you're going to use the quadratic formula, which comes up next, this is the way you would normally do this. Okay. And you could factor that. See, you can factor that. Yeah, that's x minus 9, x plus 1, right? And then we would have our two solutions here. And I'm going to kind of shortcut this there. If x minus 9 is 0, obviously x is 9. Hopefully you're realizing that. And here, hopefully you can see that x would have to be equal to negative 1, right? And if you can't see that, it's because x minus 9 equals 0 or x plus 1 equals 0. Right, so you get those two solutions, okay? And that's what we got up above, okay? But I'm just going to emphasize that in this lesson, okay, we want you, oops, nice spelling, Shanley, that was great. Oops, nice erase, there we go. Getting the hang of it. So brand new Apple Pencil, iPad, got all the toys. Now we want you to use completing the square, okay? All right, I'm going to do a couple more for you. All right, I don't want to slam you and make this video last forever, okay? But I'm going to do a couple more. I'll try to keep this video under or around 20 minutes. Let's look at number 9, okay, which is kind of similar, okay? Number 9, we've got x squared minus 10x equals negative 9, okay? So again here, we want you to, with this part, we want you to complete the square, okay? So let's think about it. Let's do some scratch work off to the side. If you have negative 10x as your middle term, right? We're going to be taking half of that negative 10. We're going to be taking half of that, right? And that gives us what? Negative 5, right? And then we'll be taking that negative 5 and squaring it. And that gives us 25, right? Okay, so that will be the magic number that completes the square, okay? So notice I did that off to the side, okay? If you can, do all that in your head, okay? That's pretty easy work. I just wanted to show you the algorithm for you take half of the linear coefficient, take half of that coefficient, and then square it, okay? So here we write it completed square, negative 10x. I'm going to use the purple because I like it. Plus 25, switch back to black, equals negative 9. And of course, what's coming up? I have to add 25 to that side as well, okay? That's very important, okay? You cannot just go and add 25 to one side and go, oh, look, Mom, I completed the square without also adding that 25 to the other side of the equation. That's important, okay? So let's finish this. Since this is a PST, how does it factor? It factors as x minus 5 squared. And over here, we get 16, okay? And we like that 16 because that's a nice perfect square, right? We can take the square root of both sides, not forgetting to write plus or minus, okay? And we have x minus 5 equals plus or minus 4. Branch off here to two separate possible equations. Either x minus 5 equals 4 or x minus 5 equals negative 4, okay? Adding 5 to both sides here, we get, and I'm speeding up a little bit here, x equals 9. Adding 5 to both sides here, we get x equals 1. And there you have it, okay? 1 and 9. Similar answers to our last one, okay? But a little different, okay? All right, let's do number 12. Now, this will be our last one in this video. I'm going over 20 minutes, but what the heck, okay? I figured this would help you, okay? I'm going to walk you through this. Negative x squared minus 3x, okay, plus 2 equals 0. Okay, all right. I'm going to do a couple of things here, okay? I'm going to do a couple of things. First, and we haven't talked about this yet. Actually, first, let me back up. I don't like the fact that we have a negative coefficient, negative leading coefficient, negative a coefficient is for negative x squared. I'm going to multiply everything by negative 1, okay? Just because I don't like looking at all those negative signs, especially the negative sign on the lead. I'm going to make that x squared plus 3x minus 2 equals 0, okay? Now, notice that we cannot factor this. It will not factor, okay? We cannot factor this, okay? If you tried to factor this, x and x, you could only go with 2 and 1, right? But what signs would make that work, right? It won't work, right? So in sort of a traditional scenario where all we're using is factoring and not this completing the square business, we would be stuck, okay? We would be stuck. So let's go back and look at what we have to do, okay? We're going to have to complete the square. Now, we haven't talked about this yet, but this is important, okay? To complete the square properly, we need to get rid of this, okay? By get rid of it, I mean move to other side, essentially, okay? Move to other side. What we need to do is add 2 to both sides, okay? Get it out of the way, okay? So maybe get rid is not the right expression. Kind of get out of the way is the right way to say it, okay? All right, we need to get that gone. So we have x squared plus 3x equals 2, okay? All right, now I've noticed I've kind of left some room kind of in here, all right, to complete the square, all right? All right, that's what you want to do. All right, now let's go off to the side here. Let's go off to the side and take that middle term and run our algorithm, okay? We're going to divide basically that 3. You don't really need to look at the x there, okay? But it's the 3 divided by 2, okay, which gives you 3 halves. And a fraction is okay, right? And we're going to square that value, and that's going to give us positive 9/4, okay? Sorry, that's not easy to read, okay? But 9/4, okay? So we're going to be adding 9/4 in to that side, and we're going to be adding 9/4 in to that side, okay? All right, now let's switch this up here, okay? We need to factor this expression now, okay? We know it's a PST because we made it one. And so how's that going to factor? It's going to factor as x plus, hopefully you'll see that has to be 3 halves squared. And that value there will always match that value there that you got as part of the completing the square process, okay? That will always be true, okay? Over here, okay, we need to add a whole number with a fraction, okay? So we're going to turn 2 into 8/4 plus our 9/4, okay? So that gives us now x plus 3 halves squared equals 17/4, okay? I hope you're following me up to this point. This is for sure the most difficult problem we've done yet, but this is why I wanted to do this one for you, okay? All right, and now what are we going to do? We're going to take the square root of both sides, okay? All right, hopefully you're with me on all that, all right? And then we have x plus 3 halves equals. Now, when we look at plus or minus the root of 17/4, we notice that we can kind of split that up into plus or minus root 17 over root of 4, right? But what is the root of 4? Well, the root of 4 is 2, right? So let me back up a little bit, okay? Let me back that up. And so what are we going to have? We're going to have plus or minus root 17 over 2, okay? Now there's only one final step that remains, and that is, since we're trying to isolate x, right? After all, that is what solving an equation is all about here, okay? We need to subtract 3/2 from both sides, okay? So now this gives us, I'm gonna do this in kind of slow motion for you here. This gives us negative 3/2 plus or minus root 17 over 2. But look at the denominators, right? We have common denominators, and this will happen. Okay, this will happen when you go through this completing the square process. You'll get that common denominator, all right? So we're gonna combine those fractions, right? And the final answer is negative 3 plus or minus root 17, all of that over 2, okay? Sorry, my 2 looked like a Z. Let me make that, that would bug me. Let me make that a little better. Make it an actual, 2, I'll get it. We're gonna finish this yet, over 2. There we go. And that is your answer for that. Negative 3 plus or minus root 17 over 2, okay? That is a good problem. That's about as challenging as any of these would get, okay? Well, I guess there are a couple more layers we could get to. We could, in another video, I'll do one where we have an a coefficient other than 1, okay? In fact, I may be able to do that now, but I'm gonna stop this video now and see if this works and post it, okay? But I want to end with one comment. I want to tell you one thing about this kind of an answer, okay? I'm going to kind of point to it here, okay? All right, normally, okay, and by normally, okay, when we learn once we learn the quadratic formula, okay, we'll see that this kind of a problem, okay, would be best or most easily done, okay, with the quadratic formula, okay? And that's coming up in the next lesson, okay? But the fact that it did not factor, right? Until we do use the process of completing the square to make it a PST, it would not have been factorable, okay? Which normally we would go to the quadratic formula, okay? So to end on kind of a concept here, okay? So there we go. Completing the square, okay? Completing the square, okay, is sort of, I'm gonna write this down, sort of like a workaround process, okay, when you can't factor, right? Once we learn the quadratic formula, we won't use it very much, okay? Okay, so I'm gonna be honest here, it's not often used, okay, in Algebra 1, let's say, okay? Okay, yet it's very important, okay? It's very important for several applications. There are several times in different levels of math where you'll use it, okay? And then the most important thing, and it helps us, this you don't know yet, it helps us derive the quadratic formula. Using completing the square will, and someday I'll show you this, it will give us the key to creating a formula that will become kind of the ultimate master key, all right? Excuse me, I didn't spell derive very well, but there we go, okay? That's just for right now a fun fact, okay? You don't have to kind of let all of that sink in yet, okay? But it is true, all right? Okay, I hope this video worked. It's just under half an hour. That was a long one, okay? I'm just gonna scroll back up through the top, see how this looks. Boy, that's a lot of math, okay. All right, wish me luck in posting this, and I hope to get better and better at doing this. All right, thanks guys very much for tuning in and following along. Peace.